Hello everyone and welcome to this course on modern application development. Okay, so now let's sort of try and understand, we have seen an example of what a web communication looks like. Let's try and understand a little bit more about what is a protocol and some examples in the context of HTTP. Right? So like I said, a protocol basically means that both sides of some communication agree on how to talk to each other. Right. So for example, when we walk into a room, the usual protocol that we are expected to follow is that we smile at whoever we see, we greet them, exchange names maybe, right, possibly shake hands. Those are all part of a protocol that we follow, okay, that's between human beings. In the same way, right, you also have protocols for how computers are expected to communicate with each other, right. Now, if I connect to another computer on port 1500, I need to know what kind of information it is expecting and what it is likely to respond with, okay. So if I go there and just start typing text, the other side is most likely not going to understand what I am talking about, okay, which is why we need to sort of have a protocol which specifies the nature of my request, what kind of responses I am expecting to see, what I am as a client, right, and what kind of responses I can actually deal with. Right. So the server now has more information about me and can respond accordingly. So the client is also asking the server for something, the server is then responding based on what the client accepted. These two things, how do they communicate with each other, is what constitutes the protocol. Now the Hypertext Transfer Protocol is a very specific version of a type of protocol, right. It is primarily text based. What I mean by that is, as you saw already, most of the actual information, the header information, is encoded as text. So you can actually read the information, right. So you can see a get and you can actually see it. It's not that it's been interpreted as get or something like that. It's not a number which got interpreted as get. It actually has get in the text, which means that if you happen to see the back and forth, you look at the bytes on the wire as they are passing by, you can see that this is actually a get request going to the server. It also, the headers can be used to convey a lot of extra information, what kind of languages you are willing to accept, what kind of encodings, what kind of response types you expect to see, and so on. Similarly, the response headers will also be in text and convey information about the message itself, right? Also about whether this information can be cached and used later, and most importantly, status codes. We already saw the 200 OK, and like I said, the 404 not found. There are many other codes that are defined as part of the HTTP specification. These are obviously the most common ones, right. 200 OK is what you hope to see most of the time. 404 happens once in a while. 500 is something you really don't want to see because it means server error, right. Something crashed, the server crashed or something happened over there, right. There are similar ones. I mean, there are a bunch of like 300 errors which are sort of harmless. They sort of are just warnings more than errors, and various different kinds of codes that are defined as part of the HTTP specification. So what are these use cases, right? As we saw already with the simple web server, GET is used for the most simple requests. It just requests information, gets back data. So most of the time things like search queries and so on, when you are like connecting to Google and doing a search, most of the time what you would probably be doing would be a GET. Post can be used for more complex data. Let's say you have a form with multiple fields in it, right? There's a name, an address, various other things. You can't encode all of that into a GET, at least you can't do it easily, right? Post is a much better way of doing this. It can accept large blocks of text. So for example, even in Gmail, when you are typing in an email and hitting send, that entire block of information is finally being posted to the web server, which accepts it, puts it together, constructs an email out of it and sends it, right. There are many other requests as well, right, some of them called put, something called delete. There are a few other variants which are much less common but are used quite extensively, especially in web 2.0, in the dynamic web, right. And many sort of APIs, application programming interfaces, including the so-called REST interface and CRUD interfaces to databases that we will look at later, are sort of built around these kind of these parts of the protocol. So just to give a few more examples, what I am going to do now is run something a slightly more complex web server, right. So, this is again a one liner. I am just running the Python interpreter, right, and the -m basically says to execute something, right, and what is that something? It basically says take the module http and run the function server from inside the http module, okay. So, in some sense this is a one line web server, right. If I go back to my shell script, I can basically kill this and clear this as well. And if I now run this command python -m http dot server, it now gives me a little bit more information than my shell script, right. It actually tells me serving http on 0000. So, this is the local IP address. Well, more importantly, this actually says on any IP address that this machine is connected to. It also tells me that it is running on port 8000. I did not specify port 8000, that just happens to be the default used by the Python HTTP server module, right. And so, now what happens if I once again run curl -v http / localhost 8000. I can see that it actually gives me a lot more information out here, okay. And this is actually surprising, when it's giving me information which is much more than what I expected, because I don't really have anything over there, right. But if you look closely at it, you will realize that what it has done is it has automatically created a directory listing, okay. It is showing me the list of files that I have, okay. So, rather than worrying about this, what I am going to do is take another couple of examples of requests that would go out when I run this Python web server, and if I use curl in order to connect to it, right. If I do something like get / and let us say I did not have this particular thing, right, I did not have a directory listing. Normally what it would do is take a file called called index.html. Let us in fact create a file like that, right. So, you can see that index.html, I created it such that it just has one line saying hello, right. Even though I call it a .html file, it does not have any tags or anything that you would normally expect to see in a HTML file. Now, what would happen if I run the same thing again? I would find that this basically responds by giving me back whatever I had in index.html, okay. This is actually part of something called convention. It is not really part of the HTTP protocol, right. This is more of a convention which says that in a given directory, if I find a file called index.html and I just get a request for the directory, right, get / or get the directory name, go pick up whatever is in index.html and send that back to the requester, okay. So, what we can see, right, I am going back over here, let us look at it in a little bit more detail. Like I said, the first 3 lines essentially, anything with the star is just debugging information. These 5 lines correspond to what was sent by curl, exactly the same as previously, the only difference being that now it is connecting to port 8000 because I told it that the server is running on port 8000. This star again basically is just extra information, right. I mean, this is debugging information from curl, but the response from the Python web server is this bunch of lines, okay. Notice one thing, it is using HTTP 1.0, not 1.1, unlike the previous one that we had, right. Makes life even simpler because 1.0 is actually a very simple version of the protocol. 1.1, even though I had 1.1 over there, actually requires a little bit more information for it to work. It also gives back information about itself. It says that it is a simple HTTP server with Python 3.9.2, that is the version of Python running over here. It gives the date, but this is part of the header, it is not something to be displayed, right. And then comes the MIME type of the result, right. It basically gives the content type and it says it is text /HTML, right. The original one-line web server that I had did not have any of this information, but ideally it should, right? Because this is what allows the browser to display the information correctly. The content type and content length are actually important in pieces of information to have. In this case, this text/html is useful. It basically says treat whatever you are getting now as an HTML file, which means basically display it. If it said application/pdf, then what would happen is it would download and probably open a previewer or something to display it. Right? Content length is 31 bytes. Well, that's because I had some information out here which was a total of around 31 bytes or so. Right? It also gives a last modified, basically telling when was the file that it's sending to you, when was it last modified. Why is this information useful? Because from the client's point of view, it might find that if you are trying to reload a page, but the server says it was last modified 1 week ago, then the client might decide, okay, I don't need to do anything, I don't need to change what I am drawing on the page because nothing has changed. Okay. So finally, we have the actual text coming back from the index.html file, right. So this is sort of the transaction that goes back and forth when you do a get slash, right, just curl http colon localhost colon 8000. Now remember that I had this file serve.sh sitting over there, right, and if I tried a request to that get/serve.sh, what do I expect will be the response? A similar set of headers from here, except that now the content type it now says is application/xsh. That's just a MIME type corresponding to a shell script. Okay. And what's the actual data that comes back? The script itself. Okay. So in other words, any file that you had, the server, if it is written appropriately, should be able to find out the MIME type, the content type, send that back to the client and also send the data as required.